Right now, it is my honor to introduce our keynote speaker, Dr. John An, an expert in chemical engineering and sustainable technologies, holding a PhD from Technical University of Munich and MBA from INSEAD and a master's degree from the University of California, Berkeley. Within the ALLATRA Global Research Center, he focuses on the environmental impact of plastics on human health and planetary system. Dr. An, the floor is yours.
So, honorable members of the European Parliament, esteemed colleagues, ladies and gentlemen, thank you for the opportunity to be here. It's an honor to speak on behalf of ALLATRA Global Research Center, along with my colleagues here. Today, we have convened to discuss a topic that, until recently, was perceived primarily as an environmental issue, but is now increasingly relevant to medicine, climate science, and public policy. The topic is micro and nanoplastics and their emerging risks. For decades, plastic pollution appeared to be a visible problem. Bottles on beaches, debris in oceans, waste in landfills. Yet recent findings suggest that the most significant consequences now occur at scales not visible to the naked eye, at the micro and nanoscales. It is well established that plastic does not readily biodegrade. Instead of disappearing, under the influence of solar radiation, temperature fluctuations, and mechanical stress, plastic materials continuously break down into smaller and smaller pieces. Plastic does not disappear. It changes scale. And when scale changes, so does the nature of its interaction with the environment. Today, these particles are present in the food that we eat, the water we drink, even the air that we breathe. They've been detected in some of the most remote places, from the pristine mountain regions to the depth of the ocean and within the human body. Our discussion will begin with a fundamental question. What happens when synthetic material designed for durability becomes a virtually permanent component of the environment and part of our bodies? To address this question, we will take an interdisciplinary approach, examining the issues across several scientific disciplines. We'll first examine how micro and nanoplastics form, how they circulate through environmental systems, and how they enter and accumulate the human body. We'll then consider the potential health implications and the underlying mechanisms, including how surface charge may enhance biological interactions. We'll also broaden the discussion to the planetary scale and explore the potential influence of plastic particles on the atmospheric processes, cloud formation, and heat dynamics. This includes recent anomalies in ocean warming, potential interaction with geodynamic activity, and a broader implication for natural disaster trends and economic stability. Today, the impact of micro nanoplastics represents a complex, systemic challenge at the intersection of public health, ecosystems, and climate.